Hello everyone, it's Dr. Ryan coming to you with another video review of one of the Step 1 Free 120 questions. Today we're going to take a look at Block 2, Question 4. So this question describes a 56-year-old man who has pain and tingling in his hands. He also has paresthesias of his feet, and because of these symptoms, they do a nerve biopsy. Now they don't show you his nerve biopsy, but they show you a normal electron micrograph of a nerve biopsy, and they label one of the structures with an X. And then the question asks, the loss of these structures, meaning the structures labeled with the X, is most likely to cause which of the following neurologic findings in this patient? And they give us 5 answer choices, which I'll let you read to yourselves. All right, so this is an extremely difficult Step 1 question. I would bet that 90% or more of medical students will have no idea what the answer is to this question and will end up guessing wildly. So if you got it wrong, do not feel badly at all. In order to answer this question correctly, you have to be able to identify structures from a normal electron micrograph of a nerve biopsy, and very few medical students have ever seen this type of image. Now, I'm no expert at interpreting electron micrographs of nerve biopsies, but I do know one thing from seeing a few of these images in PATH conferences and grand rounds, and that's that by electron microscopy, myelin is dark black. And so if you look at the image in the question, on the right side of the image, there is a dark, thick black ribbon surrounding a structure. That's myelin surrounding a neuron. And so what you're looking at on the right side of the image is a large myelinated neuron. Now over on the left side of the image, you have a number of smaller circular structures that do not have a black myelin ribbon around them, and one of those has an X on it. And so these are small unmyelinated nerves. That's what they're indicating with the X. They want you to recognize from this picture that they are pointing to a small unmyelinated neuron. Now, even if you figured all that out, you still don't know the answer, because they want you to look at these 5 answer choices and identify the answer choice that represents something that would be lost if you had damage to small unmyelinated neurons. And so this is another step you have to take in order to answer this question. And so you have to remember that small unmyelinated neurons carry information about pain and temperature sensation. And so if one of those were lost, that would lead to answer choice C, loss of pain and temperature sensation. That's the correct answer. Like I said, this is a super difficult question. I bet 10% or less of medical students get this correct. There's always going to be a few questions like this on your STEP exams. That's why no one gets a perfect score. So just don't get too bothered by these questions. Make your best guess and move on. All right, let's look at the wrong answer choices. Answer choice A is decreased sensitivity of the deep tendon reflex. This is not correct. You would lose your reflexes if you have damage to motor neurons, and motor neurons are large and myelinated. They are not small and unmyelinated like the ones denoted with an X in the image. Answer choice B is impaired stereognosis. This is also incorrect. If you don't know, the term stereognosis refers to the ability to identify structures by fine touch. This is basically a way of describing the fine touch sensation, and that is carried by large myelinated fibers, just like proprioception and vibration sensation. Answer choice D is muscle atrophy. This is incorrect. This would also occur if you had damage to motor neurons, but those are large and myelinated. And then finally, answer choice E is vasoconstriction. So if you had loss of sympathetic nerve fibers, that would lead to vasodilation, not vasoconstriction. And so that's why this answer is wrong. There are small unmyelinated fibers that are part of the sympathetic nervous system, but when they're damaged, what you get is vasodilation, not vasoconstriction. Vasoconstriction is what happens when those neurons are working. And that concludes our video review of the Step 1 Free 120 Block 2 Question 4.